Hello everyone, myself Ashutosh Sadaya, and in this video we will cover different memory shapes. So there are many types of random access memory. They exist in the form of different shapes that can be plugged into the motherboard. Memories existent in the form of chips called DIP from the beginning. The full form of DIP is dual inline package. Nowadays memories generally exist in the form of different shapes, which are cards that can be plugged into the connectors for this purpose. So let's see them one by one. The first is dual inline package, in short DIP. Like I said at the beginning, different versions of RAM were installed as a single chip, usually 1 bit wide DIP. In some cases, this was soldered right onto the motherboard, but mostly it was installed on the socket, offering a simple method of removal and replacement of memory. As the amount of memory and the need for speed increased, manufacturers started to market modules containing several chips that allowed for easier installation and larger capacity. These modules come in variety of physical configurations. The second such configuration is ZIP. The full form of ZIP is Zig-Zag Inline Package. It was intended as a replacement for dual inline packaging. The package's pins stick out in two rows from one of the long edges. The two rows are staggered by 1.27 mm or 0.05 inch, giving them zigzag appearance and allowing them to be spaced more closely than a rectangular grid would allow. These pins are inserted into the holes in a printed circuit board, with the package standing at the right angle to the board, allowing them to be placed closer together than DIP for the same size. The next shape is SIPP, Single Inline Pin Package. One of the first module forms of DRAM, the SIPP, is a printed circuit board with individual DRAM chips mounted on it. SIPP module looks like a rectangular card with a single row of pins along one edge. As you can see from the image that there are different DRAM chips mounted on the card, and you can see the pins below the card to insert this package into the motherboard slot. And the next shape is Single Inline Memory Module or SIMM. They are similar to SIPs with one exception, that they require no pins. The 30-pin SIMM has 30 contacts instead of pins in a single row along the lower edge. You can see SIMM in the image and you can clearly see the contacts in the image instead of pins. SIMMs quickly replace the SIPs because they are easier to install. A 30-pin SIMM can have as few as 2 or as many as 9 individual DRAM chips mounted on its circuit board. Although SIMM modules can have pin count as high as 200, but in PC, 30-pin and 72-pin versions are the most common. A typical motherboard of the time offered SIMM sockets capable of taking either single-sided or double-sided SIMMs with module size of 4, 8, 16, 32 or even 64 MB. The next memory shape is DIMM, Dual Inline Memory Module. As memory subsystem standardized around 8-byte data interface, the Dual Inline Memory Module has replaced SIMM as the module standard for the PC industry. DIMMs have 168 pins in 2 or dual rows of contacts, one on the each side of the card. With the additional pins, computer can retrieve information from DIMMs 64 bits at a time instead of 32-bit or 64-bit transfer that are usual with SIMM and earlier modules. The next is RIMM. The name RIMM is not an acronym but is a trademark of Rambus Inc. The RIMM connectors have form factors similar to DIMMs and fit within the same board area as the footprint for a DIMM connector. They have 184 pins compared to DIMM's 168, but use the same socket specification as a standard 100 MHz DIMM. The major elements of Rambus memory subsystem include a master device that contains RAM ASIC cell called RAC and Rambus memory controller RMC, direct Rambus clock generator DRCG, RIMM connectors, RIMM memory modules and RIMM continuity modules. So let's see some important questions. The first is explain DIP, Dual Inline Package. Next is explain SIPP, Single Inline Pin Package. The next is explain SIMM, Single Inline Memory Module. The next is explain difference between SIMM and DIMM, single inline memory module, and dual inline memory module. And the last one is explain RIMM. So that's it for this video. In this video, we covered topic of memory shapes. Hope you understood all about memory shapes. Thank you.